Hi there, this is session 15 of programming from the very basics using Python. In this session, I will talk about importing modules one more layer deep. So I already have covered how to load modules from the standard library, but I'll go a little deeper into the aspect of what modules are in this session. First of all, we have learned already from the previous session that you can always import a module by using the import statement. So I can use import and provide any module name, like say import time, and then I can actually use the members of time module in my program. So I can actually use something like time.ctime, for example, to find out what the current time is in a human readable format as a string. There were other modules I would have covered, like just in the previous session, I talked about itertools module and I told you how to use zip longest from itertools. If you're not finished the session, session 14, you can go back and have a look into it. I did cover that in that session. Now, coming back here, I should tell you about what these modules are. Well, this is the important part of your Python program structure. Let's say that if you write a C program, if you're a C programmer, if you're not done C programming, don't worry about this. But if you have done some bit of C programming, one of the common traits in a C program that you see in a program structure is that you consider your program as made up of functions, right? You normally start a C program with a function definition. You'll define a function called main, which is the main code in which you will invoke other functions. So this function-based breakdown, I would say procedural breakdown. Functions are also called as procedures. This procedural breakdown and structure is inherent in the style of writing C program. If you've been using some languages like Java, for example, your program structure is primarily made up of classes, which means when you start a program, you start with a class definition, and you might have a main class in which you define the main method, which would have the main code where you'll instantiate objects of other classes and invoke methods on them. So that's their structure. So you can think of a program in Java are made up of classes and their instances being used in their ingredients or their methods. And a C program, I could say that's made up of functions. A Python program is primarily made up of modules. If you create a file with a .py extension, for example, that is actually a module. Let me just show you right here. So if I want to create a new file now, I'm just going to create a file, new file this time, and select Python file in this case. And I'm going to just put some variable definitions in here. Let's say user is equal to John Doe. And let's say maybe score is equal to 67. And let's put in some more definitions. Maybe I could also use another definition. Let's say maybe I can load another module in here. I can just say import time. Don't worry about this. For now, I'm just importing a time module in here. And let us assume that I will also define a function. Well, I have not talked about function definitions yet. Don't worry, I'll be covering another session dedicated to function definitions and all their prototypes. For now, let's consider a very simple function. To define a function, you can use def keyword. Function definition is also a compound statement. So you'll actually use def to define a function, followed by the function name. So let's say I want to create a simple function, a very silly function. Let's call it square, which will take in an argument. Let's call that argument with a variable name as x. This is an argument variable, or also called as positional parameter or positional argument called x. And this function would return a value which is x into x. You can see that I've used the return statement here. Return statements are valid only inside function definitions. So a function can return a value to the caller. And I'll also add in some code here. Let's say I'm going to print user is equal to user, score is equal to score. And I will also try to use another line where I'm just going to say time now is time.ctime. And I'll also try to print one more print statement where I'll say square of 2 is, I'm going to call this function square of 2. This is how you call a function that I just defined. So when I call square of 2 like this, a functions can be called. You can call a function passing a parameter. Whatever you pass as 2 here, that will be assigned to x. And now this function returns x into x, which is 2 into 2. You know what the answer would be? 4. Let me save all of this entire code into a file, and let's call this file as some name. Okay, I think the file say went behind. Okay, let me just select this. So let me call this as testprogram.py. I'm just calling it testprogram.py. It's a dummy name, right? Now I created a file with a .py extension. And as you can see that if I want to run this program, I can run it from VS Code, but I will show it on a terminal. So if I'm using a terminal here, let me also tell you that a couple of you might be using Windows. So if you're using Windows, I have remotely connected to one of my Windows VM that's running. Hopefully it's still alive. Yeah, it is. So this is your Windows terminal, by the way. I guess you know how you get this. You can just go to Anaconda prompt, right? So you can just, as usual, go to the taskbar in Windows. In the taskbar search for Anaconda prompt, and you get this Anaconda prompt icon. Open that, and you have this terminal coming up, right? So I'm using a Linux terminal where I've remotely connected to a Windows machine, so it's fine. I think the inside ingredients are the same. You'll see something like base and your prompt, the Windows prompt. I've created a user called CSB, which is Chandrasekhar Babu as 3 letters. Anyways, doesn't matter. And you can see that I will go to Python samples in here. And I can access that file here. Oh, the file is not saved on Windows. I guess I need to do that. All right, we'll do that in a while. But for now, let me show it on a Linux. You can go here and you can actually try to type Python and the file name, right? The file name would be testprog.py. This wouldn't work in my machine because this file is, I've saved this file on my Linux system and this file is not really in a shared folder or so. So that is something, a problem, right? And it doesn't matter. So it throws an error. But if you save that file in this appropriate folder as testprog.py in the VS Code, if you run in Windows, you will see something like this. If I'm in my Linux system, however, so here, if I just try Python testprogram.py, you can see this program got executed, and it's a no-brainer. It's showing exactly what happened. So I'll do one thing. I'll just keep the terminal on this side and reduce the size of this particular IDE window. You can see how they're related. So basically all these are definitions in this program. I've defined a variable called user, which is equal to John Doe. I defined another identifier variable. I use that words interchangeably. It's all the same, right? So in this case, it is 95 that acts like a variable, right? So score is 67, and I did import time, and I also defined a function called square. Then I'm actually using those variables are defined in here, and you can see there's, and even invoking ctime function from time module, and I'm also calling the square function here. You can see the result, the outcome. You can see user is equal to John Doe, score is equal to 67, and time now is time.ctime. That's the output of ctime, and square of 2 is 4. You can see that right here. Now, in case you want to use this entire program like a library in another program, you can also do that. I'll show you how that can be done. Now let me create another program here in the VS Code, and this time, okay, as usual, I'll use let's go to the file menu, select new file, Python file, and here I'll just try to do this. What I'm going to do is I'm just going to use import test program. I've created a file called testprogram.py. That name of that file without the extension can act like a module name. It's a module name. So I can just import test program here. And you should also note both of these files would be saved in the same directory or the same folder, right? Both of these files are in the same folder. This file also I'm going to save in the same folder. I will talk about using modules from another folder a little later. But for now, just do what I say here. You can just try to save this file in the same folder. Before I go ahead and save this file, I'm going to put some more code here. where I can just say print. This is, let's call this as, module test .py running. And I'm just going to use print test program dot user. That's in module test program dot user. I guess I need to increase the screen size for now. Let's do that. Yeah. And print in module test program dot score, print in module test program dot square of 3, for example. And also I'll say in module test program dot time dot see that. Now I'm going to run this program now. Let's see what happens. Let me save this file as module test.py. The file is saved. And as usual, let me just go and check it up at this moment. So I'll just try to type Python module test.py on my terminal, right? You can also run this in VS Code. You'll get a terminal tab and it runs there. You can try it out, but I always recommend having a separate terminal for testing a program with Anaconda prompt. I think I covered that in session 1 and session 2, right? Follow that. It's much more cleaner, right? So if you run this, just see what happened. The code that was there in test program.py got executed. The moment you said import test program, all the lines of code, all the statements of test program got executed. All the print statements got executed. That's why you can see the output of test program.py coming first. After which, you'll see all of these lines are nothing but print statements from module test.py, right? You can see this test module.py running. You can see that line here. You can access all the variables from test program or all the identifiers defined in test program with this prefix test program dot name. Do you see that? Within test program, I had to access it directly. I could just call user score time.ctime square. All the definitions in this file, I can access them in this scope as is. It's defined in this file, so I can access it directly from here with the same name. But if you want to access it across another file, let's say test module test.py here, this time, the moment I say import test program, I'm treating test program as a module. It's like I have a lot of reusable functions and classes and a lot of variables in test program. I want to use those variables and functions and so on in another program, right? So because I want to use another program, which is module test.py, I can just say import test program, and then that loads the module. And then after the module is loaded, that file is loaded as a module. I would say test program.py is loaded as a module, and after which you can access all the definitions of test program with this kind of a prefix module name that you imported as dot the members, which means that all definitions in your .py file, that's your Python program, they get scoped into that Python module, right? So you can see that test program.py is loaded as a module here, and scoped to this module, all of these members are accessible. We also call this as a namespace. What exactly are namespaces? Namespaces are just a mechanism to avoid naming collision. What I mean with that, let's say in real world, we could have people with similar names, same name, right? Sometimes there could be two or three people with the same name as John, let's assume. So if I call John in a room with three people who are named John, all three will look at me, right? So that's the case. How do I differentiate one from the other? One of the common things that we people do as human beings, as most people, right? They normally have a surname or some kind of an initial that they try to seemingly make it unique, right? So there could be a one person by name John Doe, another person as John Smith, another person could be John something else. So if I can differentiate each of those names by using the surname or the initials, if you prefer to use initials. So the initials or the surname in a way act like namespaces, right? So within a family, I could just call John as John. I mean, John is part of my family, I can just call him John. But outside my family, somebody else want to address John, they might normally use the full name officially, right? As long as there is no naming collision, they could call John, but they believe there are many people with the same name John, they could actually call them with the full name. It's a very common thing that we do. If you have two programs, let's say I have this program called module test.py and I have created a score here. Score is equal to 100. The score, the variable called score, is defined in module test.py. Now it's belonging to module test.py. And that score you can access right here. Print score is equal to score. I can access it directly right here. You can even see this. There's modification. When I run this, you can see that the score in module test is 100, but the score from test program is 67. Was defined in test program, right? Test program score is 67. Within the scope of test program.py, I access score as score. But outside that scope, if I'm using it as a module in another file, I should say test program.score. Maybe I want to use module test in another program. Then if you want to access module test or score, I mean, you want to access score of module test, let's say module test or score. Maybe there's another file which is going to import module test, import test program, both of these independently. Then there are two scores. One score defined in test program, one score defined in module test. So I could actually say test program.score to get the score from test program module, module test score to get score from module test. So two distinct, they're seen as two distinct identifiers now. Though the names are same, they're scoped to the namespace. And this module name acts as a namespace. Now, some of you might ask, what if there are two modules with the same name? Well, that is very difficult. Think about it. Every module, at this moment, every module is a file. You can't have two files with the same name in the same folder, right? No operating systems will let you do that. At least the OSs that I know, whether you have Windows or Linux or Mac OS. Try creating two files or two folders with the same name in the same location, it'll fail. If you create one file with that name, you have to choose another name for another file in that folder. So the operating system ensures that there are no duplicate file names. So file names are unique, and these unique file names can be treated as namespaces. Well, unfortunately, in the human world, that doesn't happen. If at all you look at my name, it is Chandrasekhar Babu. That's my full name. If you do a Google search, spelling my name correctly, Google search, the first few links would be relevant to me. My LinkedIn account, my YouTube video channels, channel details, and my website profile, all the stuff related to me. I don't know how it is today, but I remember a couple of years back, it was a little embarrassing for me because when I try to see how will I rank on Google search engine when I search my name, when I do Chandrasekhar Babu, I think in the last search link in the first page itself, you would hear one of these news story link being coming up. It says, a notorious rowdy called Chandrasekhar Babu was hacked to death. Wow. I'm alive, right? And I'm not a rowdy, all right? Okay, so the problem is that in human world, namespaces have not really been followed through in a very strictest of sense. That is why we governments identify us with some unique IDs, that like the social security numbers, or in India, it's the very popular thing, the Aadhaar number. The Aadhaar IDs are unique, right? So you uniquely identify individual person. So you use some kind of special identifiers. Even in companies, it's very likely that people might have same names and same surnames. I've seen that happening a couple of times. So their best way to differentiate is obviously by employee ID, right? So use some kind of unique identifier. But that's in scenarios where you're dealing with humongous amount of data, right? But here you're treating programs. So mostly when you're designing your program, name your program with an apt name, which is not super generic. Don't try to create a program that looks very generic in nature if you want to focus on reusability. Let's say you write some Python code, and you believe that this Python code or the Python file has a couple of functions, and these functions are useful in other projects, a lot of other projects. How do you want to name that file now? Let's say I've called this file as logger. I'm creating my own logger module, and this logger module takes care of logging all activities on the system. So I've written some utility functions for doing that. So I've called this as logger.py. The problem here is that there's a standard library module called logger. I think it's called logging, actually, logging. But there could be a third-party library called logger. Somebody else would have created it. So it's very likely it's going to have a collision, right? It's like your brand identity, right? You find a unique brand. You don't want to create a spin-off brand, right? Or something else. So you want to make sure your brand names are unique. In real world, I think brand names are definitely unique. You can't have two popular brands of products, the same name. Imagine another company comes up and says, my brand name is Apple, or my brand name is Lenovo, or my brand name is Samsung. Oh, that would be a violation. For all you know, if you go to the international markets, you can get sued. This has happened a couple of times, I guess, right? So you can see that names are supposed to be unique. The file name of a Python program can act as a module name. Now, because of this nature, you should also note that the module name is an identifier. Right? It's an identifier. It's not a string. It's not in double quotes. The moment you say import test program, it defines a new identifier by name test program matching the file name test program.py. It'll do that pretty much. It has to match test program.py. Now, if I create a file with special characters in them, like spaces, if I create a .py file with test space program or test hyphen program, let's do that. Let me just try to rename this file here. I can do a save as, right? I'll do one thing. This test program.py, let me do a save as test hyphen program. Test hyphen program. Now, in my Python prompt, or in my shell prompt, if I'm going to run Python, I say Python test hyphen program.py is not a problem. As long as the operating system can save files with this hyphens in them, it has no issues. It worked. But if you're in a Python program, right now I'll go to the Python prompt. I can also load a module within a Python shell, right? But try to say import test hyphen program, throw a syntax error. So if you want to treat your Python file as a reusable module, there are certain rules you need to follow. The file name should start generally with an alphabet, rarely with an underscore. You can start with either an alphabet or underscore, the file name, right? But I would recommend using alphabets. Don't use underscore unless you are trying to say that this is some internal module and not to be used by others and so on. There are conventions where you start with underscore, right? I'll talk about that a little later. But then let's say I have to start with an alphabet and they should contain only alphanumeric characters and underscore in them. No other special characters are allowed. Not even space, dollar, cap, percentage. None of these are allowed. A dollar, any of these things, right? They're not allowed. So you have to make sure they're only made up of alphanumeric characters overall, or underscore if necessary. Maybe I could have called this test underscore program. It would have worked because it's a valid identifier name. So as long as the file name follows the proper identifier naming convention, you can use it as a module, right? So for example, if you even save this file as one test.py, it will not work because identifiers cannot start with a digit. You cannot start an identifier with a digit in Python. Python doesn't allow that. It's a language grammar syntax and language syntax grammar, and that makes sure that all names must start with either an underscore or an alphabet and only contain alphanumeric characters and underscore within them. So follow that as a norm. And it's always suggested that when you define any modules or any files or .py in general, don't use capital letters because the identifier name for the module is same like variable names or function name. They're all small letters. There have been historically modules created in the early generation which used to start with capital letter, or it could uppercase letters, or can contain uppercase letters following camel case convention and all that. That is being deprecated, right? People now have resorted to convert them all to all small case, right? Use all small case and underscore. That's something you should know about the naming convention for a module. I told you that you can always treat any file with .py extension as a module just by importing them. And modules are just objects. What really happens is this. When you type Python and let's say module test.py in this case, you pass an argument to Python, module test.py. I'm in a Python prompt. See, I'm in a Python prompt and I made this mistake. It won't work, right? It threw a syntax error. What really happened? Within a Python prompt, you cannot type Python file name. You cannot do that. You should exit the Python prompt. You should be in the shell prompt in order to run this command. You say Python module test.py and you can see that it runs. The moment you say Python and any file name, what the Python runtime would do is it reads the source code of that file. Obviously, you're passing the source code, the .py file. It parses the source code, checks for syntax correctness, indentation correctness, and also ensures that you don't have you haven't mixed tabs and spaces. All those checks are being done. Parse time. When your code looks good, no syntax errors, indentation is consistent, and you're not using mixture of tabs and spaces, the code is then compiled into bytecode in memory. It's not stored on disk, it's in memory. It creates a bytecode in memory, in RAM, and then it switches to runtime mode. From compile time, it switches to runtime mode. And what the runtime does is it creates a couple of modules. Modules are just objects. Two modules are important for us to note. There are many other modules created, but two vital modules that are created. One module is called built-ins. One module is called built-ins. There's another module which is called main. But I call it main, it's actually spelled out as _main . That's the name of the module. Every module would have a name. There's one module with the name built-in. It's called built-ins or built-in. I need to verify that, right? It used to be plural. I think it became singular recently. But there's another module with the name _main . This is the first time I think I'm introducing you to an identifier that looks like this. You'll find it all over in Python when you start going beyond the very basics, right? What is this? Python follows an interesting naming convention. There are a couple of identifiers in Python that start with 2 underscores, end with 2 underscores. These are called as dunder names. That's a Python term used, dunder. Dunder stands for double underscore, right? So we call them as dunder names, dunder attributes, right? We use that term quite frequently in Python world. We also call them as dunder methods. If it's a function which starts and ends with double underscores, it's called a dunder function or dunder method. Mostly they're all methods, right, of some object. So you'll see them a lot in Python. So this is why they follow that naming conventions, to indicate that these identifiers have special meaning. So it's suggested that you don't create your own variable, your own custom variable or custom name that start and end with double underscore. It's generally considered a bad practice. You can do it, but it's considered a bad practice. So all names starting and ending with double underscore is, in a way, unofficially I would say, reserved for the Python runtime. Python runtime treats all these names with different meaning. It applies a different meaning to it. So basically, the program that you loaded, let's say this module test.py, when I say Python module test.py, when you try to run this, I told you that Python creates a module with the name main. I'll just call it main, but you know that when I say main, it's surrounded with double underscore. It's difficult for me to say dunder main and double underscore main double underscore all the time. So when I say main, I always mean main surrounded by 2 underscores. So it creates a module with this name. And a module, I would have told you some time ago, is like it's a box or a bag with a lot of items inside it, right? A lot of items inside it. It's like a bag that you want to carry along with you with a lot of objects inside it. You're traveling out, you carry a backpack, and I told you the backpack can have your laptop, could have some stationery, some water bottle, snacks, and whatever. So these are different objects you're just going to package together and carry along. So a module is more like a package in the same manner. So main is such a package. But I would say for the large part, the box is sort of empty. The package is empty to begin. It creates an empty main module. Well, it's not 100% empty. It's like when I buy a backpack, there are certain things which are already bundled in the backpack. Maybe the backpack had some labels in them, it had some stickers inside them and all that. So there are some basic attributes that are there, which does not concern me much, right? So yes, the main module would have certain attributes, but it's not of a big concern to us. But one of the important features of every module, including main module, is that they have an internal dictionary. What is a dictionary? We saw that. A dictionary is what? A key value pair. Key value pair. It's a collection of key value pair mapping. Now, this main module's dictionary is largely empty. Largely. I'm using the word largely. There could be some members which Python uses for internal usage, but largely it's empty. Now, this module is created with an empty dictionary. What really happens after that is it starts executing statement by statement of the bytecode, compiled bytecode in memory. The bytecode is compiled in memory. It now starts executing statement by statement. In this case, the moment you see import test program, this involves loading a module by name test program. It uses a module loader, which is part of Python, to load a module by name test program.py. That creates another module object that allocates a module object. And now what happens? In the main module, the dictionary has a key called test program, and the corresponding value would be a reference to the object. Which one? The test program module object. The test program module. And then it sees this line, score is equal to 100. First, the right answer is evaluated. 100 is a literal data. So based on this literal data, it allocates an integer because it's an integer syntax here. So it creates an integer object in memory. Then it creates another key called score in the module dictionary. That's main module's dictionary will have another key called score, the value for which would correspond to this integer object, 100. So what's happening? Every definition inside your program ultimately end up creating entries in the module dictionary. The entries would involve the names acting as keys, and the values would be the reference, or I would say the address in this case, of the actual object that they refer to. Right? So this is what happens. And that's the main module. And the moment it sees a print over here, now print is an identifier. This identifier is not yet defined by me. It should be elsewhere. It tries and checks whether print is defined in the main module. If it's not in the main module, it goes and resolves to the built-in module. Remember I told you there are two modules created, built-ins and main. Main module represents the code you're running. The built-ins module represents all the pre-built functions as a part of Python runtime. The Python runtime comes with a lot of built-in functions, print, input, len, and all the functions we talked about, and all the types we talked about, all the constructs we talked about, range, enumerate, zip, and everything. Where are they? They're all part of built-ins module. They're all packaged inside built-ins module. Python keeps it in a separate shelf, built-ins. Whenever you try to access any name in your module, in this main module, the program that's running as main module, it tries to resolve the name, checking whether the name is defined in main. Have I defined a function called print here? I've not defined it here. Because I've not defined it here, what does it do next? It goes and checks up in the built-ins module and see whether the built-ins module has a definition for print. Basically, built-in module will also have its own dictionary, and the dictionary will have a key called print. Reference to it will be the function, print function, which is part of Python. It'll go and invoke that function, passing the string object that's just created. This will end up creating a string object. The string object passes an argument, and print now does this job, printing constant output. So all the built-in functions are pre-packaged within Python runtime under a module by name built-in or built-ins. The name can sometimes be singular and plural. It varies, right? We'll see that. Now, when I say test program is what? Test program is an identifier in the main module that you're running that has a dictionary. In that dictionary, there's a key called test program. How did the key come up? Because I did import test program. I told you that the job of importing a module or defining score all creates keys in the main module's dictionary. I just told you that just a while ago. A key called test program exists in main module. The corresponding value to it is the address or reference to test module object. This dot is an operator. What does it do? It resolves contents of an object or attribute of an object. So what this does this time, it tries to hop on to test program module, whatever module got loaded as part of test program, and then checks up its dictionary. Every module have a dictionary. Test program has a dictionary. Checks whether the dictionary has a key called user, and then resolves it to the value for it. And that's how we're able to access the string. So this is how your entire program is just made up of modules interacting with each other in Python at the very high level, right? So just to give you a pictorial representation, all these I just showed with hands and waving hands and all that. So maybe I'll just try to bring up a browser, a default browser, and I will just show it to you with a small diagram. I'll just drop a very small live diagram here. So as I told you that the first, when your Python program is loaded, it creates two things. First, you have the bytecode here. The compiled bytecode is loaded into memory. After the bytecode is loaded onto memory, then two modules are created. Let's represent the modules as some block like this. Yep. Let's call this one module called main. And there is another module. There's another module which is called built-in. Let me move this. Let me move this below. The built-in might also have a dunder, right? Double underscore surrounding it. And every module will have its own dictionary, as I mentioned. So let's represent a dictionary. I don't know. I'll just use any block here. So I think let me use a simple rectangle. I think it should be fine. This main module has a dictionary. And so does built-in module. So every module will have a dictionary, right? So a largely empty main module is created. It's actually not empty. The main module would have certain predefined entries inside them written up by Python runtime. Every module will have it. Main module also has it. One of them is a reference to built-in module itself. There will be a key called built-in predefined in here. So let's try to make this a little big and let me add a key here. There's a key called built-in. And the corresponding value to it in the dictionary would be the address of built-in module. I put some arbitrary number here to represent address, just putting in hexadecimal. Let's say 3A21678 or some number like that. Not a proper memory address, but I think they should do for now, just for our very basic understanding. So this sort of refers to this built-in module object. And this built-in module has a lot of entries in its own dictionary which correspond to all the built-in types and functions which are all objects in memory now. You would have a function called print, and there'll be an address corresponding to print function. Some number corresponding to the function print. Let me put a function block like something like this. So let's say a function called print here. There's a point to this. Similarly, you would have input. You could have multiple records, right? I'm just drawing one line, but you could have multiple records. You could have one record for print, one record for input, one record for len, one record for range, int, float, str, every construct, every identifier, built-in identifier, you'd find some references in the built-in modules dictionary. Main module would contain all entries based on what you define in your program. In main module, loading another module by using import is also a definition. So when I say import test program, what does it do? It loads test program. So about a loading test program, another module is created with the name test program here. Let me move this across. A module by name test program is created, which will also have a reference to built-in, by the way. It will also have reference to built-in. Every module will have its own reference to built-in, right? That's one thing. And it'll basically read test program.py in memory. It'll do the same thing. It'll compile the source code of test program and create a bytecode. Another chunk of bytecode is created for test program. And that test program's bytecode will be executed statement by statement. As a part of its execution, all the definitions that are there in that bytecode, they make up entries in test programs dictionary. For example, you'll have things like square, you'll have score and user and all that defined in here. After this program is loaded, then you'll have a key called test program, which represents the module here, test program, and it'll have the corresponding memory address. I'm just going to put some random number at this moment. Let's say 0x 2233445566, whatever number that is. And maybe this would refer to this module. And then after that, when you see the score is equal to 100, when you use that, basically what it does is it creates a key called score. Ultimately, the value would be the memory address of the object representing the integer whose value is 100. So maybe you'll have 0x, some number, 654320, some number, let's assume. And this will be the memory address of an integer created somewhere in memory, which is, let's say, an integer whose value is 10. And this would correspond to that memory address. Yes, this is how your memory layout is. It's all scattered across. And for those of you who are inclined and come from some systems programming background already, if you're new to programming, don't worry. But people who come from C background will say, where in memory is all this created? All of these happens on your program heap. If you consider your Python program as a C program, compiled C program, and it's an executable, and you load it. If you come from C background, you heard about all these segments, like you talk about the text segment or the code segment, which represents the functions and all the instructions of your Python binary. And then they have their own static data segments, and there's a dynamic data segment, which is also called as heap. That's where all the dynamic allocation happens. All of these are dynamically allocated. Modules, dynamically created. Bytecode, dynamically loaded, right? And all these ingredients like variables and all other objects are all dynamically created. So it all happens purely on heap. So you look at your Python memory model, it's not very complicated like you come from Java background and other languages. They have a very complex memory model there, memory architecture there. But in Python, for all consideration, everything in Python happens on Python heap. Some of you might ask, what about stack? Actually, when you call a function, that's where stack frames are used. In summary, stack is like a segment that maintains a state for a function. There are frames created for every function call. If you come from C background, you'll talk about stack frames and other things. So basically, if at all I call a function might have its own local variable defined. Local variables are identifiers which are scoped only inside the function, only to be used inside the function. When the function exits, all the variables of the function are lost. So in Python, the stack is also an object. For every function, a frame object is created. A frame object is created. What we call as stack frames in other languages is actually an object that's dynamically allocated when you call a function. That happens only when you call a function. The act of calling a function allocates a frame object based on the function's definition. And the frame object will decide how many variables are required and allocates a frame for that. There are some cells in the frame that represent all these local variables placeholders, and they get filled up as you start using them, right? And when your function exits, when your function returns, the frame object is destroyed, garbage collected. Talked about garbage collection. No references, they get garbage collected. I oversimplified it. There are other nuances I should talk about. And that's a topic for another future session. But for now, it suffices to tell you that everything in Python is an object. Everything, right? Even the funniest part is that variable I told you, right? All these variables, score, test program, print, these are names which are technically strings which act as keys in a dictionary. So even the variables are actually strings stored in a dictionary as a key, which means strings are objects. You can see everything is an object here, right? So it's an interesting one. So this is how your program loading or module loading happens. Now, this whole namespaces work quite naturally when you are running as a part of main module. When I say Python module test.py, the module test is running as main module, and everything that defined in that file will go into the main modules dictionary, which you can access directly. Anything that is not defined in main would be by default resolved via built-in. Suppose you look for print, it's not defined in main, so it looks up in built-in. If it's not defined in main, if it's not defined in built-in, that's where you get an error, name error. Name error, so-and-so, name is not defined. You would get that. But if you want to access members of other module that is loaded via import, every module becomes an object, and those module names are identifiers in main module. You say test program like this, test program. You refer to text program in main. When the moment you say dot and you say square, it'll resolve to test program, looks up its dictionary, and tries to access square or score or user. The namespaces are just a very natural runtime phenomena because of this. And I found this design the best in terms of modular design. A lot of these design from Python, in Python, is inspired from a language called Modular and Modular 2. I told you, Python takes a lot of inspiration from Modular 2 programming language for its modular design and a bit of object orientation of the early days, right? So it takes a lot of inspirations from there. Even the earlier design of Python, if you'll see things like self and so on coming up there, they're all based on Modular 2, right? So I'll say that. So yes, so this is what you should know about Python's modularity. Now coming back, let me go back to a terminal here. So when I actually type Python module test.py, module test runs as main. If you want to know as what module a program is executed as, right? You can always print it by using a special identifier. I can just type module test.py is running as name. There's a special built-in identifier in Python, which is called _name _. I'm just simply calling it name, but you can see there are two underscores surrounding them. And when this is a under name here, this will represent under what module name that this code is running. Okay, I'm going to put the same line, a similar line in testprogram.py, and you'll see some interesting thing there. I copied it in testprogram.py. I'm going to rename this, of course, change the string here, sorry, not rename, to testprogram.py. Let me now do something. In the Python prompt, I mean in the shell prompt, right, in the Anaconda prompt, I'll just type Python testprogram.py. Oh, I put in the wrong file. I saved it as test-program.py. Not good. I'll delete that file, but let it be there just to keep you aware that that file cannot be used as a module. I'll copy this, go back to testprogram.py and paste it here. Save it. If it's a Python testprogram.py, you can see testprogram.py is running as main module. Do you see that? So because I said Python testprogram.py, main module was created and all the bytecode of testprogram.py was executed in the scope of main module. What do I mean by that? All the definitions that happen would be added in the main module's dictionary. So it means that test_program.py is running in the scope of main module. It runs under main module's namespace. But if I'm going to run Python module test.py, now what runs as main module? Module test.py runs as main module. Because module test.py runs as main module, if I'm trying to import test_program.py, even that code gets executed, right? In here, just see this. Have I saved this module test.py? I've not saved it, I guess. Yeah, I didn't save it. Let me save it and run. Python module test.py. You can very well see that module test.py is running as main module. What about test_program.py now? Because I imported this as a module in another file, another program, which is running as main, you can't have two mains. So whenever you import a program as a module, it'll run under its module name. You can see that. Test program is running as a separate module. A new module is created called test program, like I showed you in the diagram sometime back. Main module is module test. Test program is a module with its own name, right? And that's how you can see the namespace is being separated. Now you should also note that any file that you run through Python file name, that is called as a main module. Your program is a module. Python programs are modules. And what module they are? If you run them directly, they run as main module. But if you import the program as a reusable entity in another file, another program, that becomes another module with the name of that file, of course, right? So you can see that your Python program structures are made up of modules. I've seen in many languages, you define namespaces by some keywords. Java, package, main, package, blah, 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 whatever. You use package keyword. I guess in C++ also uses namespace, right? Many places, even in Perl, you uses package declarations and so on. In Python, you don't do all the stuff. A file name acts as a module name. The file name acts as a module name. The act of creating a file with .py extension itself creates a module. So your Python programs ultimately are nothing but modules. Every Python file, right? Which means all your Python files are reusable by default. Reusable. But when you talk about reusability, there are certain things which might not look very intuitive. Let's say that if I say Python test_program.py, having all this printed is perfectly fine. All these prints coming from test_program.py, it's fine when you run this as a program. But if I include this as a library in another program, I don't want all these prints to come up. Because the reason why somebody is including test program in another module is they just want the function or some member there, right? So what do you do? Well, all you need to do is add the small statement at the end. A good design for modularity in Python is when you're writing any Python file, it's very common when you put all the definitions on top, defining variables, defining functions, defining classes, maybe loading other modules, all that you put it on top. And then if you have anything to be printed, if you run this as a program, you put this in a special condition like this. If name equals main, and put all these statements in here. All the statements in here. What I'm trying to say is that if this program is run as the main file, main module, then all these print statements will be executed. If this condition is true, when is condition true? If name is equal to main is true, when you say Python test_program.py. If you say import test program in another .py file, this condition is false. Because this condition is false, none of these statements will be executed. So now look at this, just by adding this clause. Now, if I just say Python test_program.py, all these lines got executed if you run this as a main program. But if I say Python, if I type Python module test.py, when I say Python module test.py, it's going to import test program. Earlier, when it's importing test program, it's executing all those lines, right? All those lines. Now see what happens. Only messages from module test is printed. All these are from module test, right? Earlier, you can see this. Before this module test running, message is printed. All the test programs message is printed when I type Python module test or py. The last time I tested it, right? But now you can see none of the messages from test program.py is executed. This is a very commonly used convention. And the last, it's not a rule, it's a standard practice. I mean, I've seen many people try to force this, but I wouldn't do that. If you have a lot of complex logic going on in here, most of the times you want to do is you can create a function. You can call that function whatever you want. Some people like to call it main. Those who come from C background like to call it main and put all this code inside that function called main and then call main like this. Which means rather than having your Python program with all print statements directly, your main program, the main logic, you put it in a function called main and invoke this at the end, like using this clause. You say, if this is run as a main module, then call the main function. I've seen sometimes people call it run, main, or any name you want. It doesn't matter. There's no rule in Python to say what you should call it as. But I've seen a lot of projects, they use this kind of a design. But I've seen a couple of other projects, they use run instead of main. It might vary. So you can choose any name you like, main or run, whichever you want. There is no consensus as yet amongst the community. Different people use different naming conventions. So some people say calling it main looks confusing. If name is equal to main doesn't read nice. So you can say if name is equal to main, call run function. And the run function could be this one. It's up to you. I'm not going to say that run is a good option or a main is a good option. I believe that functions must be verbs, actions. So run is a better idea. Main does not represent action. Maybe it says it's a main code. That could be an argument. People who come from C background would generally relate to that. But mostly you see a lot of code, they use run in here. So when you use this kind of a design, it's all the same. If you say Python module test.py, none of these code got executed. The user is equal to, time now is equal to, square of 2 is equal to, the sprints are not executed. But however, if you just say Python test program.py, you're running this module as a main program. You're running a module as a main program. Sometimes people use the word module and files interchangeably because of this, because all .py files are ultimately modules. So you can say run this module as main. What do you mean by that? Run that .py file as main. So how do you run it as main? Python file name. When you do that, the run function is called, and the run function does all the job. This is a very commonly agreed upon structure for a Python program. Any sizable Python code, you'll have this structure inculcated. So this is the basics that you should know about what are modules, what really happens when you load a module. And I told you how a simple .py file, assuming that the naming convention, the name of the file is following the identifier naming convention, can be treated as a module in another programs, and how you can create reusable Python code by putting all the definitions on top of your .py file and having your main code in a structure like this, in a style and structure like this. And this way, you can run this as a main program and use all these members which you defined, or you can use these members in another program just by importing it this way. This is a major part I should talk about when I talk about loading modules. Now I'll tell you about some syntax sugars. Sometimes it's calling test program with the full name test program is very difficult. I'd say test program.user, test program.score, test program.square. Having long names can be very inconvenient. It's a very practical thing, right? So if at all I say my name is Chandrasekhar Babu, nobody will call me with a full name. They'll call me Chandra, CB, CSB, short names. We all have been accustomed to using short names, right? To commonly used modules or commonly used entities or objects. So we can do the same thing in Python. For example, this time I go to the Python shell. I went to the Python shell. if I just say import test program or type test program dot user, everywhere I use the prefix test program. But instead of this, I'll exit Python shell again. That's why I'm not demonstrating Jupyter Notebook, because every time I import something, it'll remain until I restart the notebook. So in Python, I can always exit, go back again, and a fresh instance, right? So go back to Python here. And now if we just type import test program as T, that clause as T means load test program as a module, but the identifier that identifies it will be called T. See this? T represents the module. So you can say t.user, t.score. So in essence, I would say that trying to run the program, like trying to load a module by using import module as new name, right? Import test program as T. When I say this is semantically equivalent to just doing import test program. T is equal to test program. Test program is merely a variable. All identifiers are like variables in Python, right? They act like variables. So every identifier, module name is just another identifier, just like A, B, C, user, score. No difference. So I say T is equal to test program. I can say test program.user, but I can also say t.user. But when I say import test program as T, it's like load test program, create a variable called T that represents that module object, but you'll not have reference to test program at all. For example, just see this. I'll go back to Python here. If I say import test program as T, I can no longer say test program dot user. That won't work because there's no identifier called test program created. Module object is created with the name test program in memory, but the identifier to identify it, the label to identify it is called T. So I have to use t.user or t.score. Got it? So this is what you should know about the as clause. It's a very common pattern that you'll see in large Python projects, especially if you're in the data analytics. You will say import pandas as PD. Or if you're using NumPy, you'll say import NumPy as NP. Import scikit-learn as SKL. Import matplotlib as MPL. Short names are very common. You'll see them being used. Or even in your standard library, it's very common to say import multiprocessing as MP. The word multiprocessing is so long, it's very easy to misspell it. So once you import it with an alias, it's easy to use the alias, which are short named, say identifiers to identify the module. It's a very common thing to do in Python, right? So this is what you should know. The last thing I should tell you is about another clause. I can also say this. I can also type this. I'll go to the Python shell again this time. I'll say from test program import user. This is very different. This also loads a module. This loads a module called test program in memory, but you don't have access to the module. You're not given access to the module because there's no identifier to identify the entire module object. Just try this. Test program dot score. It is used in scenarios where you have a module with a lot of members inside it. A lot of members. You're not interested in the entire module. We don't care about the module. You're only interested in the particular member in a module. So what do? You say from module import a specific member, and that member is added in your current namespace. So user is available here. You don't say test program.user. It doesn't work. You can't say t.user because you not use anything like t here. You have to just type user. Yes. So what it really does is it loads a module called test program. Then it creates an identifier in main called user, or reuses the identifier if necessary. If user was already defined, it will be clobbered, right? The existing user is clobbered. It's redefined, reassigned to test program's user. And therefore, you can access a member of a module. You don't have to worry about t dot or test program dot and so on. You want to import members from another module into your current module so you can access it as a direct identifier in your current module without a dot operator. you can use from module import member. You can also use comma separation import multiple members. For example, you could say from test program import user comma score comma square. So you can see score, square of 5, all works. So if you, for instance, if you had square already defined in your code, let's say square is equal to 1, 2, 3, 4. This was the value of square at this moment, which I defined in my code. And then if I run this from module import member like this, the square which I earlier defined is lost. So square will now be, sorry, score, not square, score in this case. Score that I defined earlier is lost. This is called clobbering. This can happen. You should be a little careful when you do this. I mean, you should be knowing it. If you're importing a module member, you should know that you don't create a variable with the same name. Or if you create a variable with the same name, but you also want to use score from there, one way to do that is this. Let's say score is equal to, let's say 1, 2, 3, 4 again. There's a score defined in my current namespace. But if I want to use score from another module also, without clobbering up my namespace, without cluttering my namespace, I can use a clause here, score as S. Now, S is score from test program. Score is what I maintain here. So you can also use the as clause when you're importing member from another module. Hope it's clear with you. All right, modules are a big topic. So I think I will be revisiting modules one more time with a little more details about features. But for now, these are the basic concepts you should know about what modules are, what happens when you load a module, and then what does import module name do, and import module as alias, what does it do, and how do you access just only few members of a module in your current namespace by using from module import member. Now, some of you might ask, when should I use import module? When should I use from module import member? The practical scenario is this. If at all you want to, import a member and the member name is very, very unique. For example, let's say I want to import socket for socket programming. It is not a good practice to say import socket. Socket is a library. It's available as a module. I could type socket of, it looks so redundant, of socket.af underscore inet, socket.sock underscore stream. This is how I initialize the socket. Let's say S is equal to this. If I say import socket, all the members of socket, I do prefix socket dot socket, socket dot afinet, socket dot sock string. But you know the fact that these members called socket, afinet, sock string are only found in socket module. You will not find them in other modules like time module or sys module or OS module. When you're very sure about that, when you know that these members come from this particular library alone and nobody else provides it, for all you know, then it's considered better to say from socket, import socket, af underscore inet, and sock underscore string. So it's easy to write a socket by telling S is equal to socket of af inet directly. Consider this hint. If you have a module name and a member of the module also has the same name as the module name, socket, the member is also called socket. Similarly, I've seen one more standard library module, which is called glob. You say import glob, and the member of glob is called glob. Glob.glob. You never want to say import glob here. You say from glob, import glob. It's always better to use it that way. So you can call glob function directly. Glob is a unique function found in a unique module called glob. Very rarely you'll find glob elsewhere, right? So this, you can import it this way. But if you have some members which have generic sounding names like open, split is a classic example, right? Open, split, it's better that you don't say from member import open. For example, there's an open function built into Python. There's a built-in function called open. So it's a bad idea to say from shell import open. No, you don't want to do that. It'll clobber the built-in function called open. If you do this, The built-in function of open will no longer work. It's going to call open from the shell module, which will work differently, which is meant for opening a shell object, which is totally different. And it's not very obvious to you when you call open. What does it do? Does it open a normal file? Does it open a shell module? No, we don't know that. Certain things like load, store, found, and you have load and dump. You'll find in pickle, JSON, YAML, many of these modules. You say from pickle import load, bad idea. You say import pickle, pickle.load. Import YAML, YAML.load. Import JSON, JSON.load. Import toml, toml.load. The load is a commonly named function found in across many modules. Such kind of common sounding names, it's always better you load the module and say module.member to avoid ambiguity. Always follow this as a practice. This will avoid surprises and confusions while reading your code. It improves maintainability. So both options are available. So in some cases, it makes practical sense to say from module import member when you know for sure that the member name is very unique and it only comes from one particular module and nowhere else. But if you think that the member name is a common sounding name that many modules could provide, it's better that you load a module by using import module and say module.member to use that member. Right? These are the differences between using import module versus from module import member. I told you the differences. Also, the last thing I should tell you that is very common practice by many new by developers, but I've seen also in a couple of production code, which is dangerous and I would recommend avoiding it, is this. If you're testing code in your REPL, it could be quite convenient. For example, let's assume that there are a lot of functions in a module called OS module. There's a module called OS. OS module abstracts operating system services. If you want to see what's inside a module, you can say dir of module. It shows you all the members of the module. It's a list. All of these are members of OS. I want to use all these functions, but I don't like to keep calling os.fork, os.link, os.listdir, os.unlink and all that. So I can simply say from OS import asterisk. The from clause, the from module import member, you can also use an asterisk here, which will import all the members of the module in the current namespace. This I would not recommend putting in a .py file. Never do that. The moment this will clutter your namespace. If you want to see what all variables are there in your current namespace, debugging purposes, you'll see so many members. Right? So this is something which you should avoid. So this is something that I recommend not doing. It's good in a REPL, but definitely not good to go in a .py file with a sizable program. If you write a 2-line script or something, it's okay, but 2 or 5-line script, it's okay. But if your code is going to be a little big, avoid this. Be very specific about what members you need to use. Specify those members and use them. This improves maintainability and readability and avoids unwanted namespace clutter. Just like throwing all the things around you in your room, everything, and you can't walk around it. You don't want to do that. You want to take only things that you need in your desk, not throw everything on your desk, right? This is what this does. This like empties your rack on your desk and see what you can do with it. It's good sometimes to search for something and all that, but in your production code, this is best avoided. Okay. The last thing I should tell you is I told you about dictionaries. Let me show you that. If you want to access the main module's dictionary, okay, I'll come out of it. Go back to Python here. The main module. Right now, this Python prompt is there, right? This is the main module. When I say Python and press enter, I did not pass any file as an argument. The default main module is now this Python REPL. We can print that. We can just say print. You can see this. Name is main. Now, if I use this function called globals, it shows you the ingredients of the module dictionary. I will maybe write in a program and show you here. Maybe I'll put this in, test program is a good example. Let me put it in test program. In test program.py, in run, I'll just print globals. That's a dictionary, right? So I'm going to print that. And if I try to run test program.py, all these are print functions output that you can see in here. All the print functions output. But the last print function is print globals, which prints a dictionary. And this dictionary represents the main module's namespace. Technically, the current module's namespace. It shows name is main. All of these are dunder attributes which you can ignore. But you can see over here, user, John Doe, score, 67, time, module time object, time module being loaded, square, function square, run, even the run is a function which I define. This is the module dictionary that you see here. There are also other functions like vars and locals and all that. I'll cover that a little later. Okay, but for now, I just told you what globals does. Globals will return the currently running modules dictionary. This is also called as a global namespace. The global namespace. So all the global variables that are defined in the top level, not inside a function, defined the top level, they fall into what we call as a global namespace, which is nothing but keys in a module dictionary corresponding to the objects that they refer to, that you see here. Right? Yes. Modules are a very interesting concept in Python. And if you understand how modules work, if you understand how you can leverage modules, how they work internally, you know Python language model very well. That's what it is, right? So Python programs are ultimately modules interacting with one another. Modularity is core of Python program. And it's a very good design, in my opinion. One of the best design I've seen amongst languages. I played with many languages, but this is a very good design. Very clean, very unambiguous, and very practical. All right, we spilled beyond 1 hour. I think it's 1 hour, 16 minutes already. So I think I did cover some part of module. I will revisit module in another layer with a little more details much later. So I hope you understood most of the concepts I covered. If you still have any confusion or if I'm not really syncing up with you, please put them on comments. Please comments and I can create another video, maybe elaborate it even better, right? I can do that. So if you find this video useful, if you really learned something, yeah, please do post it on comments. At least I know that you people are finding it interesting. Yeah, I see one of you have posted a comment. I really like it. So this way I know that I'm going on the right track. Okay, so do post on comments to see how I'm doing, by the way. And yeah, do like the video if at all you have found this useful. And also, if you're not subscribed, if you subscribe to my channel, you will see every time I'm posting a new video, I guess you'll get notification. All the YouTube deal, right? So thank you very much. So meet you in the next one.